good afternoon to everyone. So my name is Bruno. You probably don't know me at all, and there's a good reason for that. I just joined Futurice, and I'm gonna present about the story, the tale of a rogue Wi-Fi access point, and what can we get, what kind of intelligence we can get from the network data with that. So as I mentioned, I just joined like 5 days ago. So it's normal that you don't know me. I already talked with a lot of you. I hope that after this I will still talk with a lot of you. So I joined as a principal architect and technology advisor. I'm on the VESA tribe, and I'm a Portuguese native, but I've been living in Helsinki already for 7 years. On my hobbies, I heard that hobbies are really important around here. I don't know what's your obsession with that, but I do love music. I love reading and traveling, and I like to do indoor climbing and technology in general. So before we continue, I will do some things in my demo that I shouldn't, but I asked IT about that, and that's okay, according with them. So I have this privacy policy, for GDPR. It's a big thing now. You can read and accept it if you don't agree. It's big. I know. That's why I generate this in one website. So don't read too much into it. There's a good website to generate fake stuff like this. In a nutshell, a word of caution: if you don't want to participate in the demo, you need to turn off all your devices right now. I'm not kidding. If you don't turn off the devices, I assume that you want to participate in the demo. Wow, okay. You guys are so... No worries, I will, like, all the stuff, I will not do anything that you will not see, so everything will get deleted afterwards, it's fine. So the topic is about Wi-Fi security and rogue access points. So a bit of, I don't know exactly your background. There's a lot of front-end developers, a lot of back-end developers. I'm not sure about network engineering type of folks, but anyway, Wi-Fi basics that everyone knows. You connect to a router, an access point with SSID, which is the network name, and then the passphrase. Usually there's a security around that, which is WPA2. And it gives you access to either an internal network or an external network. It gives you access to internet usually, but it can also just, for an internal network corporation, do that. So it can give you access to both, for instance, if you use here the Futurice Helsinki, it gives you to internal and also external access. If you use the guest access, the guest network will give you just to the internet. So these are the basics when you connect. So the SSID is basically the names that you see there when you are looking for. So how can we provide a wider coverage, Wi-Fi coverage, to the same network? And the answer is multiple access points with the same SSID, meaning that it doesn't matter where you are in this office. If you are always connected to Futurice Helsinki guest, it doesn't matter if you are there or there, you always get the internet access. Why? There's not only a single router or a single access point, there's multiple of them. And they're all connected to the same network. So the principle is that since there is not a single access point, you can actually list all the access points that are available to you. And if you look, for instance, you will see that in OS X actually has really nice tools to list this. Everything is native. I didn't have to install anything. And you can see, you can make a scan and you can see all the networks, all the SSIDs, what are the access points and what are the strength of the signal and what kind of encryption is available. And your device will always connect to usually the one that is nearest, but also can be the one that has better signal, which is not necessarily the nearest one. The frequency and channels, for instance, if the frequency of the Wi-Fi of this access point is conflicting with another one, it will connect to a different one because it's too full. So usually the formula varies also according with the vendor. So Apple does it one way, Dell will make it a different way depending on the chipset. When we want to extend the Wi-Fi coverage, we usually add a new access point. And let's put an example that we just got access to another floor. Apparently it will be true. And IT will, for instance, put a new access point there. And to do that, they will just use the same SSID, the same passphrase, the password. and they will be connected to the same physical network, right? It is simple as that. Now, if this is only that what requires, what to add a new access point, what if we don't connect to the network? Meaning, what if you see here, the new access point, which is this green one, is connected to the same router as all the other ones. But what if it's not? So what if instead of connecting to that router, if we just connect directly to the internet? It's a guest network, so you don't necessarily need you don't have internal resources, right? And this is a core principle behind a rogue access point. Because if the only thing that I need is an SSID and a password, anyone can create an access point. The SSID and the password are over there. It's written on the wall. What prevents me to do it? That's right, nothing. So I can create something that I call rogue one. A rogue access point is an unauthorized Wi-Fi access point, and I use the Raspberry Pi to do so, and there it is. And basically a Raspberry Pi with a power supply to get some energy on it, and two Wi-Fi dongles, one to connect, one to provide our Futurice guest Helsinki, and the other to connect to the internet, because we need to connect somewhere, right? And to connect to the internet, I'm using my phone. That's meaning that normal my phone, you make an access point, something connects to it, and I gave you a good heads up about it because it is actually running already. So I've been running this for a couple of minutes with the blessing of IT, of course. I have no idea. I'm not storing the traffic. I'm just forwarding people to the internet, just as an example. But what are the core building blocks to do this? Like, how easy is to do this? I had 1 day to do that and make the slides. Took me more time to make the slides than to make that. I'm not even joking. Basically, you need 3 different things in the Raspberry Pi or in Linux. You need 3 components. One is the host FD that basically provides you the access point management. It allows you to create an access point. Then you need DHCP CD, which is basically gives you all the clients that connect to it. It gives you the network information. So that it's a dynamic host management system. Basically, when you connect to it, you don't need to specify your IP and net mask or anything like that. You get that from the network, which is what this component does. And then DNS mask T that gives the clients the DNS, the domain name service. And then connecting to my phone, the other device, and it uses a WPA supplicant, which is a standard in Linux to connect to a Wi-Fi network as a client. And then just simply IP tables and IP forwarding to forward the traffic between one Wi-Fi dongle to the other Wi-Fi dongle. And that's basically it. And you can provide internet to the world, right? But you can also forge it. And I kept the Ethernet cable available during my tests, and there's a good reason for it, meaning that with my Ethernet cable, I'm using just to connect as a console to it to see what's happening there. It's not being used to forward the traffic or anything, but just for you, I will use it as a demo if the demo gods allow it to, just to show you around. But what can I do with this? What's the purpose of this? With this, when you connect to the Wi-Fi, in this case to this access point, to this Raspberry Pi, from within, I can see, if you are connected to it, I can see everything that is happening. I can intercept the network traffic, meaning that in a raw level, using a native Linux tool called TCP dump, basically I can see that all the network packets that are crossing between one and the other. Meaning in this case, I'm basically running TCP dump in the access point USB dongle, so this one here, and I'm seeing all the stuff that is happening to it. Of course, can be very daunting. So filtering this a little bit, there is a tool called T-Shark, which means terminal Wireshark. If you know Wireshark, it's kind of the terminal version of it. And it allows you to make kind of fine-grained filtering. but it also allows you to export the output to JSON. So the cool thing is that you can, basically with this command, I'm just interested in seeing all the HTTP traffic, ports 443 and 80, so SSL and non-SSL. And then I'm making some fine-grained filtering just to take, because it's still a lot of information, to take just the interesting bits. Meaning that by just running that command altogether, I will see from anyone that is connecting to the rogue access point, I can see where are they browsing to. Meaning if they're connecting to an API or to the website, I can see it all. Now, this also allows you to do man-in-the-middle, meaning normal interception, I'm just seeing what's happening. I'm not doing anything. I'm intercepting the traffic, I'm letting it pass. With man-in-the-middle, I can actually make some damage, meaning that I can actually change what are you getting. For instance, since I'm controlling the access point, instead of giving you the page that you requested, and that's on the internet, I can change it. I can modify the page that is serving to you, and to you will be transparent. And there is a nice tool called Man-in-the-Middle Proxy, and it basically allows you to see all the HTTP and HTTPS traffic that is happening, and it allows you to basically change the request and response. Sorry, not the request, sorry, the response. It gives you kind of fine-grained tooling on that. And even on this case, even if you just want to like debug and troubleshoot, is also nice for that. Now, I'm actually being avoiding talking about SSL too much because there's a reason for that. Meaning that why is so important to have HTTPS everywhere? You probably heard that, but the reason is that when you are using websites with HTTPS or with SSL, sorry, there's an encryption. Meaning that I cannot see, even as a man in the middle, I cannot see what's between the client and the web server. I cannot see what's the content of the things. I can, however, serve something completely different. And I can try to forge an SSL certificate. Meaning that, yes, with this man-in-the-middle proxy, you can get in the way of the SSL because you are controlling the access point. But if the client, meaning that if your laptop doesn't trust the certificate authority, you will get a warning and you cannot go undetected. Meaning you get something like, instead of getting something like this, you get something like this. This is a typical SSL man-in-the-middle. And you see that you get this kind of warning like, hey, do you want to proceed or not? Probably you saw this. You usually see this when a certificate expired, but also when it's invalid. And you actually, if you compare the information on the certificate, you actually see that, yeah, the certificate is not trusted because it's self-signed. Of course, you can redirect the traffic to somewhere else. Now, before I go to this, maybe let's make some actually real-world examples of this. So I connect with the network cable just to get some kind of console access, just for you to see how it looks. So you can see that in one way I'm connected to, in the one device I'm connected to my phone, and in the other one is I'm the guest, Futurice guest Helsinki. And if you actually see the space, you can see the MAC, can I see the MAC address? Yes, you can see the MAC address of the access point. So when we are listing in OS X all the stuff that is available, you will see my access point here somewhere, which is B0 something, this one. Now, there is one tiny problem that I didn't have time to solve, which is that, as you know, there's a lot of different protocols and speeds in Wi-Fi. You have this B, N, G, and AC, which is the latest and greatest one. And the thing is that actually my hotspot, my USB dongle doesn't support AC. So that's why you see it here with B, G, and N and not as an AC. In the same network, you can have both. But the biggest issue is that iOS and OS X will by default connect to the one that is faster. So meaning that I cannot connect via Wi-Fi to my own Raspberry Pi. Only if you have older devices, it will be connected. But Nowadays, there's very little devices that do not support this. So in order to actually make a demo, I cannot actually use the guest Helsinki properly. And I apologize for that in advance. But if we go and check, for instance, host D, if we go and check here, if I change the SSID to something else, let's call it rogue one. Just and let's restart this. My rogue one hotspot now should be appearing as rogue one. Yeah. Now, if you want, you are fully free to join that network. You will see what I will see here, so I'm not taking anything. But I will join from my laptop. I didn't change the password, the same that is there. So if you want to join, it's the same as the guest. Feel free. So just for you to see what's happening, if I will use my iPad just to simulate some traffic. So you will need to take my word for it that I will be connected to the Rogue One network in this case. Okay, I did connect it. So I'm gonna make just some TCP dump with the basic traffic. And you can already see that there's a lot of things going on. I'm not sure if any of you joined it, but there's a 1 plus 60, so one of you at least joined. This is not a 1 plus 60. There's a 5T there, you can actually see it. So you can already see some traffic going on. What exactly, you don't necessarily need to use a Wi-Fi with a password. You can actually use something like totally open. For instance, you can use, when you go to Compi, you have a free Wi-Fi called Compi Free. So there's no password. I'm not sure if any of you uses the Compi Free Wi-Fi. If you do, then you will probably connect to this automatically as soon as I do. If not, it's okay. This is just for educational demo purposes anyway. So I will connect from my iPad here to Compi Free. Unsecured network is connected. You can see. Okay, no traffic going on. Let's generate something. There you go. Going to CNN and it should be appearing there. All right. So what else can you do with this? Now let's do something a bit more funny. Let's, for instance, since you get the DNS also from the access point, you can give something completely fake, right? Meaning, I can change, for instance, what appears when you go to futurice.com to the people that are connected to this. So in this case, I need to restart DNS mask, but it should happen pretty fast that when you go to futurice.com non-SSL, let's see. So this is the kind of things that you can do. You can basically manipulate the entire information. Now, getting back a bit to the presentation, because I'm not sure, I'm racing now against time, but when you have so much data, it's very hard to kind of figure out what can you do with it. And one of the things that I really, really like to use for this quick data visualization, if you want to call, is something called Splunk. I'm not sure if you ever use it. If you use something like Tableau, Elasticsearch is on the same type of note. It's really nice to explore these raw events. And even though you shouldn't install Splunk in a Docker container, I actually did, just for quick tryout of it, for you to see how it is. And it basically is nothing too complicated. You just install from the Debian package and you put some default password because it doesn't come with that. And you need to, because it's Docker, you need to do something to allow that file system because it's a workaround, that part. But bear with me on that. And basically you can get it up and running very quick. I if you look at the command, I'm also mounting a local volume with a Docker container because to share the data between the rogue access point and that. And basically it will look like this. Now I'm gonna actually show you how it looks from Splunk itself. So the data that you gather, that I'm only filtering HTTP traffic, and it gives you stuff like this. And so this is the one JSON event, so from one packet. And very quickly, what you can do from this timeline is, for instance, if I want to see what are the top destination hosts that is connecting to, and you just click like that, and very quickly you get that from to where is it connecting the clients here. But also you can see what clients are connected to the access point. So you can actually go and see source host. And actually here you see the traffic going back and forth. But you can see that my laptop was one, also my iPad was another one. Very quickly you can see this. You can also do like from here, only for my iPad, tell me which ones are, so what kind of hosts was my iPad connected to? Only my iPad. And very quickly you can gather things like this. You can also create dashboards with that data. And the beauty of Splunk is that you actually don't need to do anything about the data schema. You have a piece of JSON, actually it doesn't need to be JSON, it can be a CSV, and you just index it raw. As you have, you put it in Splunk. You don't know the format, you don't know anything. And you just need to add that data there. Automatically, Splunk will discover what are the fields, what are the things, and it gives you that kind of structure. If you never used it, give it a try. It's really nice. The free license only allows you 500 megabytes per day indexing, but it's enough for you to try something. Then you need to pay, obviously. If you are doing ML, it comes with an ML toolkit, which I don't recall the name now, but it's based in Python. You can actually run Python commands on this. So it's really, really, in a way, powerful for that. And since I'm running out of time, I actually wrote an article at some point about this topic. So you can actually take a peek into that. It's in my medium.com account. And that's it. Sorry if it was a bit rushed in the end. Thanks. Any questions?
Thank you. Super interesting stuff. Any questions?
Is there any best practice besides working like behind the SSL as a victim? Should I do anything else?
Yes. For instance, when you are in this, do not connect to free Wi-Fi's. That's my first advice. Unless you don't have any kind of other means to it. For instance, if you are on your phone and if you have 4G, just use the damn 4G. Like, don't be cheap. Like, if you connect to a free Wi-Fi because you are traveling and you don't have another possibility, at least use a VPN. Why? Because when you use a VPN, it basically encrypts the entire tunnel. And yes, you could, for instance, when you are connecting to a VPN, you could kind of forge like that I am the VPN server, but usually VPNs come like with client certificates and with passwords, a lot more heavy things than the normal HTTPS. So you cannot successfully establish a connection to a secure VPN like that. You cannot forge that. So VPN, really, really good advice. If you are also if you're in your laptop and if you have to randomly connect to like this type of networks, you can also use, for instance, Google DNS servers or OpenDNS. The problem with that is that if you are trying to access a network that has internal resources, then you cannot do that. But yeah, VPN is kind of like the easiest advice that I can give you on that.
So like Wi-Fi isn't a new thing. Is there a reason why like somebody hasn't solved this in some way? Like somehow verifying that all of the Futurice guest Helsinkis are actually the same network instead of the rogue ones around?
There are solutions to it. The problem is that it affects the user experience. For instance, you could allow only clients that have a certain client certificate to connect to it, or you could try to make random checks with that, but it is really hard. Also, in Wi-Fi, there's something called Wi-Fi AWPA2 Enterprise that provides like a radius, and the radius is basically a server. Okay, the biggest example of a radius is that you go to the airport, you connect to the free Wi-Fi, and it gives you when you go, it connects you to this kind of, goes to a web page that you need to accept and say like, hey. So that basically is connecting to an internal server, which is a radio server, and you can kind of like authorize or not the client, sometimes even based on the token or things like that. It's a lot harder to fake that.
But it's annoying as well, though.
User experience. User experience there. Or you cannot, yeah. It's the same thing as like, why wouldn't you connect to an open, like no password type of Wi-Fi? It's a lot easier, right? But then, okay, now there's a password, there's a bit. So there's a lot of this type of variants, yeah.
Do you have any advice on how you would protect yourself from man-in-the-middle attack with an uncertified SSL certificate when you're using a command line to send like a curl command, for example? Because I guess from the browser, it would verify that if that is a authorized provider for the SSL, but I'm not sure if you have that from the command line.
You also have that from, actually you have that from everywhere. Like curl also gives you that. And actually if you're trying to connect to HTTPS to a website that is insecure, you actually need to really allow that with -K. I'm not sure if you ever saw that. Basically when you're using curl, if you're trying to go to, let's say, google.com, this of course will work. If the certificate was invalid, it will appear like a warning. Actually, not a warning, it's an error. You cannot connect unless you do. So unless you do that with the -K, you will not like. But you really need to do this. Use this flag if you want to allow insecure connections. So you always get that anyway.
Yeah, so that answered my question. Thank you.
I don't have a question, but I once read from a person who was having a free Wi-Fi, like a Wi-Fi inside his house, and then he noticed that the neighbors are using his Wi-Fi as well, and then he put this kind of man-in-the-middle server between so that it would actually serve all the content, but it was just serve all the images upside down. And you can find this internet, like how to set up this squid proxy in between, and that was probably fun for the neighbors.
Yeah, exactly. If you control the access point of the network, you can do pretty much anything that you might imagine. Even with the SSL, it's not fail-proof, meaning that if you manage to, you can always redirect, for instance, the client to another website that has a valid SSL certificate. So you can put like a redirect. So if you are serving a website in HTTPS with signed by something that your browser think it's valid, and very simple, if you use AWS, if you use API gateway, it gives you an HTTPS URL. That certificate is valid for any kind of web browser. So you can just redirect from, let's say, futurice.com to HTTPS API gateway amazon.com, and you get a green sign in your browser and you actually don't see it. So there's always kind of ways to work around it. It's a lot harder, but it's possible.
So I don't have a question. Similar story with what Uka had. So there was this TV show on the BBC many years ago about scams and hackers and whatnot. And then very similar to this, a guy goes into a hotel lobby, sets up his own Wi-Fi proxy there, man-in-the-middle attack, and he makes this fake captive portal site where people have to enter in their credit card information.
Yeah.
They send in the credit card information, he proxies them forward to the internet, and in the meantime he buys pool tables and whatnot, new Ferrari, and
yeah.
So.
Making those landing pages are really, really easy to do. And it's a pity that I cannot change the Wi-Fi here. Maybe I can do it after this, but basically he saw in his phone, you go to a website that you think it's like futurice.com, and all of a sudden you get different web page that you were expecting. And you can also there's tools where you can actually download an existing website and serve it as yourself. So basically create a mirror of a website. And this is very common in banking phishing attacks. Basically try to visit a website that looks like your bank, but is not your bank, and you put the credentials there. So there's multiple type of schemes that you can do with it.
Regarding that, I'm not sure if that's what you're referring to right now, but I know that sometimes people buy domain names with the symbols that are not like the English ASCII symbols that looks like, well, some popular banking domain name.
Yeah.
And like, how do I make sure that, for example, if I'm logging into a specific app, like that's, well, that app, or is there any way I can somehow check that the domain name is the correct one? And yeah, that's my question.
That's a really good question. Well, really pay attention to in your browser, to what's written on the bar. Having the green symbol is not just enough, but the green locker. Really make sure that the name is what you are expecting. Of course, in the background, if the website itself is compromised, there might be something going on there, but there's not really a way for you to tell. If the website itself, if the legit website was compromised, then you cannot do anything about it. You don't have that control. But of course, that's very, very hard unless someone got really sloppy with their practices. But usually what's written on the bar is really good. And if you have like some security product installed, usually there's kind of this reputation checks. And I guess Axel knows where I'm going with this because we used to work together in F-Secure Labs, and that's actually what we were doing, which is basically reputation analysis for domains and for URLs and for files. So there's always, if you have a product that makes this type of security checks, like is this domain valid or what is this? I think that's a good practice to have.
Well, I guess it's better to write the domain name by yourself instead of following the link if you want really make sure that you are going to the right banking site.
Yes. And usually, just to complement what you just said, if you get like an email with this kind of like advertisement, really make sure when you are opening the email that you check where is the link going to, because that's a very, very, very common way of attack vector. Is to send like a crafted email that comes from your bank, but is actually not. And then when you click on the link on a nice image, it sends you to something that looks like your bank, but it's not. So, yeah.
Actually, on the topic of typing your URL yourself, I've kind of gone away from that, and instead I just put it in Google. That way, if I actually typo it, then Google will correct it, and I can actually click the correct link, and not kind of typo it and end up on a phishing site that looks identical.
But
if it was Google where you wrote it.
It's really...
Yeah, but I have Google in my history, so I'm pretty sure that Google is okay.
But actually, on that note, that is a common mistake that what you shouldn't do.
Okay,
and
tell me why.
Because, for instance, if I'm making... Okay, it's very hard, for instance, if it's a very famous bank to do that. But let's say that you have an account on a small bank. If I create a copy of their website, and if I pay Google to promote that, if I have a... Let's say that my credit card is infinite amounts. If I pay them, it will jump to the top first because it's on the sponsored ones. So when you put the name of the bank on the Google search, it will actually, the first result might not be that.
Yeah, but I won't click the sponsored one. Those are marked. But the first one, that's an actual one.
All right.
And it's like a visitor site or something.
All right, then it's good.
Thank you once again.
Thanks, guys.